Welcome to the next video of section 4, ammo spawning. In the previous video we've learned about ammo prefabs. In this video we'll see more about ammo spawning. The ammo prefab created so far presents us with a technical problem that, if not taken seriously, has the potential to cause some serious performance penalties for our game. Specifically, when the spaceship weapon is fired, we'll need to generate ammo that launches into the scene and destroys the enemies on collision. This is fine in general, but the problem is that the player could potentially press the fire button many times in quick succession, and could even hold down the fire button for long periods of time, and thereby spawn potentially hundreds of ammo prefabs. We could of course use the instantiate function seen already to generate these prefabs dynamically, but this is problematic because instantiate is computationally expensive. When used to generate many items in succession, it will typically cause a nightmarish slowdown that will reduce the FPS to unacceptable levels. We need to avoid this. The solution is known as pooling, object pooling, or object caching. In essence, it means that we must spawn a large and recyclable batch of ammo objects at the level startup. A pool of objects that initially begin hidden or deactivated, and we simply activate the objects as and when needed when the player fires a weapon. When the ammo collides with an enemy or when its lifetime expires, we don't destroy the object entirely. We simply deactivate it again, returning it to the pool for reuse later if needed. In this way, we avoid all calls to instantiate and simply recycle all ammo objects that we have. To get started with coding this functionality, we'll make an Ammo Manager class. This class will be responsible for two features. First, generating a pool of ammo objects at scene startup. And second, giving us a valid and available ammo object from the pool on demand, such as on weapon fire. Ammo Manager features an ammo array member variable which holds a complete list sequential array of references of all ammo objects to be generated at startup during the awake event. Ammo array will be sized to pool size. This refers to the total number of ammo objects to be generated. The awake function generates the ammo objects at the beginning of each level, and these are added to the queue with enqueue. Once activated, each ammo object is deactivated with setActive false and is held in the pool until needed. Ammo Manager uses the queue class from the Mono library to manage how specific ammo objects are selected from the pool to be activated when fire is pressed. The queue works as a first-in, first-out FIFO object. That is, ammo objects are added to the queue one at a time and can be removed when selected to be activated. The object removed from the queue is always the object at the front. The enqueue function of the queue object is called during awake to add objects initially to the queue, one by one as they're generated. The spawn ammo function should be called to generate a new item of ammo in the scene. This function does not rely on the instantiate function but uses the queue object instead. It removes the first ammo object from the queue, activates it, and then adds it to the end of the queue again behind all other ammo objects. In this way, a cycle of generation and regeneration happens, allowing all ammo objects to be recycled. Ammo Manager is coded as a singleton object, meaning that one and only one instance of the object should exist in the scene at any one time. This functionality is achieved through the static member Ammo Manager Singleton. To use this class, create a new game object in the scene called Ammo Manager by selecting Game Object, Create Empty from the application menu. Then drag and drop the Ammo Manager script from the project panel to select the object in the scene. Once created, drag and drop the Ammo Prefab from the Prefabs folder to the Ammo Prefab slot for the Ammo Manager component in the Object Inspector. Now, the scene features an Ammo Manager object to hold an ammo pool, off-screen and hidden. However, still nothing about our existing functionality actually connects a fire button press from the gamer with the generation of ammo in the scene. That is, we have no code to actually make the ammo visible and working. This connection should now be made via the player controller script that we started in the previous section. The class should now be amended to handle ammo generation. Then recoded player controller class is included in this code. Player controller now features a turret transform array variable listing all child empties being used as turret spawn locations. During the update function, player controller checks for fire button presses. If detected, the code cycles through all turrets and spawns one ammo object at each turret location. Once ammo is fired, reload delay is engaged, set to true. This means that the delay must first expire before new ammo can be fired again later. After adding this code to Player Controller, select the player object in the scene and then drag and drop the turret empty object onto the turret transform slot. This example uses only one turret, but you could add more if desired. Now you're ready to play test and fire ammo. By playing the scene and pressing fire on the keyboard or mouse, left click, ammo will be generated. Excellent! However, on testing this, you may notice two main problems. First, the ammo appears too big or too small. Second, the ammo sometimes bounces, flips, or reacts to the player's spaceship. Let's fix these in turn. If the ammo appears wrongly sized, you can simply change the scale of the prefab. Select the ammo prefab in the project panel, and from the object inspector, enter a new scale in the transform component. If the ammo appears to bounce or react to the player's spaceship, then we'll need to make the ammo immune or unresponsive to the player. To achieve this, we can use physics layers. In short, both the player's spaceship and ammo should be added to a single layer, and all objects on this layer should be defined as immune to each other in terms of physical reactions. First, select the player object in the scene. Then, from the Object Inspector, click on the Layer drop-down and choose Add Layer from the context menu. Name the layer Player. This is to indicate that all objects attached to the layer are associated with the player. Now, assign both the player object in the scene and ammo prefab in the project panel to the newly created player layer. Select each and simply click on the layer drop-down, selecting the player option. If prompted with a pop-up dialog, choose Change Children also. This makes sure that all child objects are associated with the same layer as the parent. Both player and ammo have now been assigned to the same layer. From here, we can make all objects in the same layer immune from each other insofar as physics applies. To do this, navigate to Edit, Project Settings, Physics from the Application menu. The global physics settings appear in the Object Inspector. At the bottom of the inspector, the Layer Collision Matrix displays how layers affect each other. Intersecting layers with a checkmark can and will affect each other. For this reason, remove the checkmark for the player layer to prevent collisions occurring between objects on this layer. With the Layer Collision Matrix set from the Object Inspector, test run the game so far by pressing play on the toolbar. When you do this and press fire, ammo will issue from the turrets and no longer react to the player's spaceship. The ammo should, however, collide with and destroy the enemies. Excellent work! We now have a spaceship that can fire weapons and destroy enemies, and the physics works as expected. Maybe you'd like to customize player controls a little, or perhaps you want to use a gamepad. In the next video, we'll explore the user controls.